We like to think we're Earth's first intelligent civilization, the first to build cities, the first to burn fuel, the first to leave scars big enough to last forever. But what if that confidence is misplaced? What if another civilization rose, industrialized, and collapsed millions of years before us, and Earth simply erased the evidence? Not with explosions, with time. Welcome to Simulation Hypothesis. This is where we slow down and question the stories we've been told about humanity, Earth, and our place in deep time. We don't chase fantasy or ancient alien myths here. We follow uncomfortable science, real hypotheses, and the kinds of questions scientists ask when they stop assuming humans are special by default. If this kind of thinking pulls you in, stay with us, subscribe, and let's examine a version of Earth that might be far stranger than we're taught. The idea that Earth could have hosted an advanced civilization long before humans sounds like science fiction at first. Most people hear it and immediately picture stone pyramids hidden under jungle canopies or metallic ruins buried beneath deserts. When none of that shows up in the fossil record, the idea is dismissed outright. Case closed. No evidence, no civilization. But that dismissal rests on a dangerous assumption, that advanced civilizations leave permanent, obvious traces. According to the Silurian hypothesis, a real scientific thought experiment proposed by climatologist Gavin Schmidt and astrophysicist Adam Frank, that assumption may be deeply flawed, not because ancient civilizations definitely existed, but because Earth is extraordinarily good at wiping the slate clean, better than we intuitively understand, better than our history books prepare us for. To grasp why this matters, you have to let go of human-scale thinking. Our entire sense of permanence is built around lifetimes, centuries, maybe a few thousand years if we're feeling ambitious. But Earth doesn't operate on that clock. Earth thinks in millions of years, sometimes billions. From that perspective, even our most durable achievements, concrete, steel, glass, plastics, are temporary graffiti. Consider how fragile our own civilization would look to a geologist 10 million years from now. Skyscrapers would collapse within centuries. Roads would crack, sink, and be swallowed by vegetation. Dams would erode. Cities would vanish beneath sediments. Even plastics, often cited as immortal pollutants, would fragment, disperse, and chemically transform beyond recognition over geological time. Within a few 100,000 years, a blink by Earth standards, there would be no visible surface evidence that humans ever existed. And that's if we vanish today. This is the first uncomfortable realization behind the Silurian hypothesis. Absence of obvious ruin does not mean absence of prior intelligence. The fossil record itself is incomplete to an extent most people never fully appreciate. Less than a tiny fraction of all species that have ever lived are preserved as fossils. Soft-bodied organisms leave almost nothing behind. Even hard structures are only preserved under rare, specific conditions. Whole ecosystems come and go without leaving a trace we'd ever recognize. Civilizations don't fossilize. Cities don't fossilize. Technology doesn't fossilize. What does persist are subtle chemical signatures, changes in atmospheric composition, unusual isotope ratios, strange sediment layers that hint something once altered the planet at scale. And here's where the hypothesis becomes unsettling. We already know Earth has experienced massive planetary changes long before humans appeared. Ice ages that covered continents, periods when the planet was nearly ice-free, mass extinctions that wiped out over 90% of life, radical shifts in carbon cycles, oxygen levels, and ocean chemistry. Earth has reset itself many times. The Silurian hypothesis asks a simple but dangerous question. Could one of those resets have erased a technological civilization? Not dinosaurs with smartphones, not humans in loincloths with spaceships, but something intelligent enough to industrialize, alter the climate, and then disappear. The name itself is deliberately misleading. It doesn't claim intelligent reptiles lived during the Silurian period. It's a reference to a Doctor Who episode, a nod to how speculative the question sounds. But the science behind the question is deadly serious. Because when scientists study our current impact on Earth, they realize something alarming. Our greatest legacy won't be skyscrapers or satellites. It will be a thin geological fingerprint, a brief spike in carbon isotopes from fossil fuel burning, unusual concentrations of synthetic compounds, a rapid temperature shift recorded in ice cores and sediments, a mass extinction layer defined by sudden biodiversity loss. That's it. That's what we leave behind. And crucially, many of those signatures resemble natural events already present in Earth's history. Take the Paleocene-Eocene thermal maximum about 56 million years ago. A sudden, massive release of carbon caused global temperatures to spike, oceans to acidify, and ecosystems to reorganize. The cause is still debated. Volcanism, methane hydrates, unknown feedback loops. But from a purely geological perspective, it looks disturbingly similar to what humans are doing now, just slower. If an industrial civilization existed before us and collapsed, its carbon signal could easily be misinterpreted as a natural anomaly. Earth wouldn't label it technology. It would label it a weird layer. That's the second uncomfortable realization. Earth doesn't care why something happened, only that it did. Brian Cox often emphasizes this when discussing deep time. From the universe's perspective, intelligence isn't special. Consciousness doesn't come with a preservation guarantee. Civilizations don't get archival protection. They rise, alter their environment, and if they fail, they vanish without ceremony. Neil deGrasse Tyson echoes this sentiment in a different way, reminding audiences that cosmic history is littered with things that existed briefly and then disappeared entirely. The universe does not preserve achievements, it preserves physics. And physics is indifferent. Now imagine a civilization that industrialized without building in stone. No pyramids, no megastructures, no monuments designed to last. Perhaps they lived in coastal regions that later sank. Perhaps their materials degraded faster than ours. Perhaps they existed for a few thousand years, long by human standards, negligible by geological ones. A few tectonic shifts later, they're gone. The Earth has recycled its crust multiple times. Ocean floors are younger than continents because subduction zones constantly pull them into the mantle. Entire regions vanish beneath the planet and are replaced by new rock. Nothing built on Earth's surface is safe on long timescales. Even if a civilization had nuclear technology, its radioactive signature would fade. Isotopes decay, signals blur. After tens of millions of years, distinguishing artificial radiation from natural background becomes nearly impossible. This leads to a terrifying implication. If Earth did host a prior civilization, we might already be standing on its grave without knowing it. Not because we're stupid, not because scientists missed something obvious, but because the planet itself is an efficient eraser. And this is where the hypothesis becomes personal. We like to believe humanity is unique, not just intelligent but unprecedented, the first to ask questions about the universe, the first to look back at Earth and wonder what came before. But deep time doesn't reward uniqueness, it rewards survival. The fossil record shows long stretches where life flourished, only to be abruptly wiped out. It shows dominant species reduced to dust. It shows entire evolutionary branches ending without ceremony. If intelligence arose once, there is no physical law preventing it from arising before and failing. The Silurian hypothesis does not claim this happened. It claims something more unsettling, that science cannot rule it out. And that alone should change how we see ourselves. Because if Earth has reset civilizations before, then we are not the climax of a story. We are a chapter, possibly a short one. That realization reframes everything: climate change, extinction, technological acceleration. Suddenly, our situation doesn't feel unprecedented. It feels familiar in a way we can't remember. Brian Cox often warns against anthropocentrism, the habit of placing humanity at the center of every narrative. The universe doesn't care about our intentions. Earth doesn't care about our achievements. The planet responds to energy, chemistry, and physics. If those get out of balance, the reset comes. Slowly, quietly, without malice. And this brings us to the most dangerous misunderstanding of all. We think collapse looks dramatic: meteors, fire, explosions, but most planetary resets are subtle, Climate drifts, oceans warm, species decline. Feedback loops reinforce themselves. By the time collapse becomes obvious, it's already locked in. If a prior civilization fell this way, it wouldn't leave a scar that screams intelligence. It would leave a whisper, one we might mistake for noise. Which raises an uncomfortable question that lingers beneath everything we've discussed so far. If Earth erased a civilization before us, what exactly will it erase of us? And more importantly, will the next intelligent species even know we were here? That question doesn't end here. It deepens. Because once you accept that Earth can erase civilizations, the next step is realizing something even more disturbing. The planet may have already done this multiple times, and the evidence might be hiding in places we haven't learned how to read yet. And that's where this story really begins. If Earth can erase a civilization, then the most important question is whether one existed before us. It's how we would ever know. Because the moment you stop expecting ruins and monuments, the hunt for past intelligence changes completely. You're no longer looking for cities, you're looking for fingerprints. And fingerprints fade. The first mistake most people make is imagining that time behaves like a slow decay. That things gradually wear down but remain recognizable if you look hard enough. In reality, geological time doesn't erode, it replaces. Earth doesn't gently age its surface. It chews it up, buries it, melts it, and recycles it into something new. Mountains don't last forever. Continents don't last forever. Even oceans are temporary features. The crust beneath your feet is not ancient. Most of it is younger than you think. Ocean floors are constantly destroyed and rebuilt through plate tectonics. Entire swaths of Earth's surface vanish into subduction zones, dragged downward and reprocessed in the mantle like scrap metal. Whatever was built there, forests, reefs, cities, is not preserved. It's annihilated. This alone shatters the idea that we would have found something by now. Found where? The Earth has no obligation to keep receipts. Geologists already know that vast stretches of Earth's history are missing. These aren't small gaps, they're millions of years long. Entire chapters gone, with no explanation beyond erosion, tectonic uplift, or subduction. If a civilization existed during one of those missing intervals, its physical traces would be gone by definition. And that's before you even consider where civilizations tend to arise. Humans didn't build cities on mountaintops or deep inland deserts. We clustered near water, rivers, coasts, fertile floodplains. Exactly the places most likely to be submerged, eroded, or tectonically altered over time. Sea levels alone have risen and fallen by more than 100 meters repeatedly throughout Earth's history. Entire continental shelves, areas that would have been prime real estate for intelligent life, are now underwater. And underwater archaeology is not just difficult, it's nearly impossible at planetary scale. We struggle to map our own submerged coastlines from 10,000 years ago. Now imagine doing that for a civilization that lived 10 million years earlier. Even if we somehow located a site, what would we expect to find? Concrete, humans invented it, but it cracks and dissolves. Steel, it rusts and disperses. Glass, it fractures into sand. Plastics, they photodegrade, fragment, and become chemically indistinguishable over deep time. There is no known building material that remains intact on Earth's surface for tens of millions of years. None, which means the absence of artifacts is not evidence of absence. It is evidence that Earth is doing what Earth does. This is where the Silurian hypothesis becomes razor-sharp rather than speculative. It doesn't ask us to believe in lost empires. It asks us to admit something more humbling. We don't understand preservation as well as we think we do. Scientists already face this problem when studying ancient life. Soft-bodied organisms dominated early ecosystems, yet they barely appear in the fossil record. Entire biospheres existed that we only know about indirectly, through chemical anomalies and isotopic ratios. Intelligence would be no different. A civilization doesn't need to leave behind machines to alter the planet. It only needs to change the chemistry of the atmosphere, the oceans, or the biosphere. And we know this because we're doing it right now. When future geologists, human or otherwise, study the Anthropocene, they won't see highways or satellites. They'll see a brief, sharp signal, a sudden rise in carbon-12 relative to carbon-13, a rapid temperature increase, an extinction pulse, synthetic molecules scattered thinly through sediments. That's the signature. And crucially, similar signatures already exist in Earth's past. This is where the question gets uncomfortable. Because once you accept that Earth's natural processes can mimic the footprint of industrial activity, the line between natural event and technological event becomes blurry. Not because science is broken, but because geology is coarse-grained. It smooths detail. It averages chaos. Brian Cox often explains this using cosmology. When you look at the universe on the largest scales, individual stars disappear. Galaxies blur into filaments. Detail vanishes. Only patterns remain. Earth does the same thing with time. Zoom out far enough and individual lives vanish. Cities vanish. Species vanish. What remains are cycles. Carbon cycles. Oxygen cycles. Climate cycles. Extinction cycles. And cycles don't carry labels. So imagine a civilization that burned fossil fuels for a few thousand years, triggered warming, destabilized ecosystems, and then collapsed. From Earth's perspective, that's just another perturbation. A spike, a wobble, something that gets folded into the background noise of deep time. There would be no plaque saying, intelligence was here. Only a layer. This leads to a profound misalignment between how humans think and how planets remember. We think history accumulates, Earth thinks history resets. And this misalignment is why we're so confident that nothing came before us. We're looking for permanence in a system designed for turnover. Neil deGrasse Tyson often points out that humans overestimate their cosmic importance because we experience reality at the wrong scale. We live in moments. The universe lives in epochs. What feels monumental to us barely registers to physics. From that perspective, the rise and fall of a technological species isn't shocking. It's expected. The universe has no shortage of time to experiment. Now consider how intelligence itself might evolve. Humans are not guaranteed. Our path was shaped by accidents, asteroid impacts, climate fluctuations, evolutionary bottlenecks. Change any one of those and Homo sapiens never appear. But intelligence as a strategy, problem-solving, tool use, environmental manipulation appears repeatedly in evolution. Birds, cephalopods, mammals, different brains, similar outcomes. There is no rule saying intelligence must wait until primates. If a non-human lineage developed technology millions of years ago, its body plan might not resemble ours. Its materials might differ. Its cities might not look like cities to us at all. It might not even prioritize permanence. Human civilization is obsessed with legacy because we fear death. Another species might not share that obsession. And if it didn't, its collapse would be even easier to miss. This is why the Silurian hypothesis deliberately avoids mythology. It stays grounded in physics, chemistry, and earth science. It doesn't ask, what if dinosaurs had lasers? It asks, what signatures would intelligence leave and how long would they survive? The answer, disturbingly, is not long. There is also a psychological barrier here that scientists are increasingly aware of. We assume progress is linear, that civilizations rise, improve, and persist. But history, even human history, suggests otherwise. Empires collapse, knowledge is lost, technologies regress, dark ages happen. Scale that up to geological time, and collapse becomes the default outcome. Brian Cox has said that the universe doesn't reward ambition. It rewards stability. Systems that push too hard against their environment tend to destabilize themselves. If that's true, then intelligent civilizations may be inherently short-lived. Not because intelligence is bad, but because altering a planet faster than it can respond invites correction. Earth's corrections are slow, but they are absolute. And once you accept that, another unsettling possibility emerges. Maybe we're not looking at a planet that's never hosted intelligence. Maybe we're looking at a planet that's very good at surviving it. That flips the narrative completely. Earth isn't fragile, we are. The planet doesn't need saving, it needs patience. If a prior civilization existed and vanished, Earth continued, life continued, new species emerged, intelligence might even have restarted from scratch. From that perspective, humanity is exceptional for being intelligent. We're exceptional for being early enough to notice the pattern. And this is where the story begins to turn inward. Because the Silurian hypothesis isn't really about the past, it's about the future. It's about whether we are repeating a cycle without realizing it. If Earth has reset before, then the question is, did it happen? It's what triggers the reset. Climate destabilization, mass extinction, runaway feedback loops, loss of biodiversity resilience. Sound familiar? The unsettling truth is that our civilization's geological footprint is already being written. The layer is forming. The signal is accumulating. Whether anyone ever reads it is beside the point. Earth will. And that realization leads us somewhere even more disturbing. Because once you accept that civilizations can vanish without a trace, you're forced to confront the possibility that intelligence itself may not be rare. It may simply be temporary. And if that's true, then the silence of the past isn't comforting. It's a warning. But that's not all. Since it also begs the question, if something intelligent lived here before us, where would its shadow still exist? The answer to this question is quite surprising, since it's not in ruins, not in bones, not in machines. It would exist in chemistry. Because while Earth is ruthless with structure, it is surprisingly careless with ratios. Atoms don't forget easily. Isotopes linger. Subtle imbalances can persist long after everything visible is gone. This is where the Silurian hypothesis quietly becomes unsettlingly practical. Modern science already uses chemical signatures to reconstruct worlds that no longer exist. Entire ancient climates have been inferred from nothing more than trapped gases in ice cores. Ocean temperatures from millions of years ago have been estimated using oxygen isotopes in microscopic shells. We reconstruct vanished worlds from crumbs. So if an industrial civilization altered Earth's atmosphere or oceans at scale, it wouldn't need to leave cities behind. It would only need to leave a statistical anomaly. And here's the uncomfortable part. Earth's history is full of anomalies. Take carbon, for example. Carbon exists in different isotopic forms. Biological processes tend to favor lighter carbon isotopes, while geological processes distribute them more evenly. When massive amounts of organic carbon are released, say, by burning fossil fuels, the ratio shifts. That shift is happening now. Future scientists will be able to identify our civilization not by what we built, but by a thin, global fingerprint of altered carbon chemistry. The Silurian question is simple: has this happened before? There are moments in Earth's past where carbon ratios spike sharply, sudden excursions, rapid warming events, massive die-offs. They're usually explained by volcanism, methane release, or orbital changes. And to be clear, those explanations are solid. No one is claiming otherwise. But the hypothesis asks something narrower and more dangerous. Could a technological civilization produce a signal indistinguishable from a natural catastrophe? The answer is yes. That's not speculation, that's physics. A planet doesn't care why carbon enters the atmosphere. It only reacts to the consequences. Which means even if a civilization caused the change, Earth would record it the same way it records a supervolcano. This is where our confidence starts to wobble. Because when you look at deep time, many of the most dramatic climate events happen fast, geologically speaking. Thousands of years, sometimes less. That's an eye blink on Earth's clock. And rapid change is exactly what technology accelerates. Another potential fingerprint lies in nitrogen cycles. Industrial activity alters nitrogen availability through fertilizers and combustion. That reshapes ecosystems globally. In sediments, this shows up as shifts in nitrogen isotopes and nutrient patterns. We already use these markers to identify human impact. Again, the Silurian question isn't whether such markers exist, they do, but whether we automatically assume they must be natural when found in deep time. Because nature is capable of violence on scales we struggle to imagine. But so is intelligence, and distinguishing the two is harder than it sounds. Then there are synthetic molecules. Humans have introduced compounds into the environment that do not exist naturally: persistent chemicals, plastics, complex hydrocarbons. These will degrade, they will fragment, but they won't vanish instantly. Over millions of years, they break down into simpler compounds, blending into background chemistry. Future geologists won't find plastic bottles. They'll find a brief increase in unusual organic fragments, which is exactly the kind of signal that would be hardest to interpret. Was it biology, geochemistry, or something else? Earth doesn't annotate its layers. This ambiguity is the core danger of the Silurian hypothesis. Not that it proves past civilizations existed, but that it exposes how blind we might be to them even if they did. Our tools are powerful, but our assumptions are stronger. We assume intelligence leaves obvious scars. It might not. Now shift perspective again, from Earth to the cosmos. Astronomers search for life on exoplanets by analyzing atmospheres, oxygen, methane, industrial pollutants, disequilibrium. These are considered potential technosignatures. In other words, we're actively searching for the very kind of faint chemical fingerprints we might have already missed on our own planet. That irony is hard to ignore. Brian Cox has often pointed out that the universe teaches humility through scale. The more precisely we measure, the more uncertainty we uncover. Precision doesn't eliminate doubt, it sharpens it. And nowhere is that clearer than in Earth's own deep past. The further back you go, the fuzzier causation becomes. We see effects without knowing the trigger. We see consequences without witnesses. Which brings us to another uncomfortable idea. Intelligence may not aim to last. Human civilization is built around permanence. Records, archives, monuments, data centers. We're obsessed with being remembered. But that obsession is cultural, not universal. An earlier intelligent species might not value legacy at all. It might prioritize survival, adaptation, or even cyclical collapse and rebirth. Its technology might be biodegradable by design, its cities temporary. Imagine a civilization that understands geology far better than we do, one that deliberately avoids leaving lasting scars, that limits mining, that regulates emissions, that integrates into ecosystems rather than overwhelming them. Such a civilization might flourish for tens of thousands of years and then vanish quietly, not in catastrophe, but in transformation. From Earth's perspective, it would be invisible. No apocalypse, no extinction spike, no clear chemical scream. Just silence, which is far more unsettling than destruction, because silence implies control. Now consider the possibility that intelligence arises not once, but multiple times on a planet, that evolution experiments repeatedly, that some lineages flirt with technology and retreat, others burn brightly and burn out. Earth has existed for over 4 billion years. Humans have been technological for maybe 2 centuries. That ratio alone should make us cautious. We are not a dominant feature of Earth's timeline. We are a rounding error. And yet we assume uniqueness. Neil deGrasse Tyson often says that the universe is under no obligation to make sense to us. That line applies just as much to Earth. The planet does not care about narratives. It records processes, not stories. The Silurian hypothesis strips away narrative comfort. It doesn't give us a lost golden age or a fallen empire to mourn. It gives us uncertainty. And uncertainty is far harder to live with. Because if Earth has hosted intelligence before and erased it without ceremony, then intelligence is not a guarantee of transcendence. It's a phase, a transient arrangement of matter that sometimes figures out how to manipulate its environment and sometimes doesn't figure out when to stop. That idea reframes our own moment in history. We are not standing at the beginning of an inevitable ascent. We may be standing in the middle of a cycle we don't recognize yet. And the scariest part is this: Earth does not need malice to end civilizations. It doesn't need intention. It doesn't need to fight back. It only needs time. Time smooths everything. civilizations feel permanent from the inside. From the outside, they're brief spikes in entropy production. And if that's true, then the real question isn't whether Earth erased a civilization before us. It's whether Earth is already erasing us, slowly enough that we mistake it for stability. That realization forces the conversation to pivot again. Because if intelligence is ephemeral and evidence fades, then maybe the absence of proof isn't mysterious at all. Maybe it's expected. And if so, then humanity's future may not depend on how advanced we become, but on whether we can recognize the warning signs before we become another thin layer in the rock. And that takes us somewhere darker still, because the strongest evidence for a reset may not be buried deep in Earth's past. It may be unfolding right now. If Earth is already erasing us, it won't look like a dramatic ending. No single moment. No clear line in the rock that says civilization ended here. Instead, it will look exactly like what we already see. Systems drifting out of balance, one by one, each failure small enough to explain away. That's what makes the Silurian hypothesis so unsettling. It doesn't require a cataclysm. It only requires feedback. In planetary science, feedback loops are everything. They determine whether a world stabilizes or spirals. A little warming melts ice. Melted ice absorbs more heat. More heat melts more ice. The system accelerates not because something new happened, but because the rules stayed the same. Intelligence, when it appears, becomes a new kind of feedback. Brian Cox often describes planets as systems seeking equilibrium. Life disrupts that equilibrium briefly, but mostly in ways the planet can absorb. Photosynthesis altered Earth's atmosphere radically, but it unfolded over hundreds of millions of years. The planet adapted. Technology does not operate on those timescales. Technology compresses geological change into historical time. And that compression may be the key to why civilizations don't last. A technological species doesn't need to destroy itself intentionally. It only needs to push the system faster than its own biology, politics, and psychology can adapt. Once that happens, collapse doesn't require an external enemy. It emerges naturally. From this perspective, extinction events aren't interruptions, they're corrections, which raises an uncomfortable possibility. Earth may not erase civilizations violently, it may erase them politely, slowly, indirectly, without ever needing to fight back. Look at the great mass extinctions in Earth's history. The Permian extinction wiped out over 90% of marine species. The Cretaceous ended the dinosaurs. These weren't single causes. They were cascades of volcanism triggering climate shifts, triggering ocean anoxia, triggering food web collapse. Complex systems fail like this, not all at once, but everywhere at once. Now imagine a civilization embedded in such a system. It would experience the collapse as separate problems: resource shortages, migration, political instability, ecological loss. Each one manageable, each one solvable. Until they are. This is where the Silurian hypothesis intersects with something deeper than geology: cognitive limits. Human brains evolved to handle immediate threats, not planetary-scale trends unfolding over centuries. We are good at reacting to predators, bad at responding to statistics. An earlier civilization might have faced the same limitation. It might have understood climate physics perfectly and still failed to act fast enough, not because it lacked knowledge, but because knowledge alone doesn't override incentives, fear, or inertia. And here's the critical insight. The smarter a civilization becomes, the more leverage it gains, but also the more fragile the system becomes. Low-tech societies can only damage their environment locally. High-tech societies can alter global cycles. That means there is a narrow window where intelligence is powerful enough to reshape a planet, but not wise enough to stabilize it. The Silurian hypothesis suggests that window may close quickly. If that's true, then technological civilizations don't fail randomly. They fail predictably. And that predictability leaves patterns. Not cities, not machines, but synchronized disruptions across climate, chemistry, and biology. From Earth's perspective, those disruptions look natural. From the inside, they feel accidental. Now consider the timing. Earth's history shows long periods of relative stability interrupted by abrupt transitions. These transitions often coincide with sudden increases in greenhouse gases, temperature spikes, ocean acidification. Again, natural explanations exist, and they are compelling. But the hypothesis asks something different. Could intelligence act as a catalyst rather than a root cause? In other words, a civilization doesn't need to create a catastrophe from scratch. It only needs to push an already unstable system past a tipping point. A small nudge can produce a massive outcome. That's what makes detection so difficult. If a civilization amplified a volcanic warming event or accelerated methane release, the geological record would still point to volcanism or methane. The intelligence would be invisible, yet essential. This reframes the question entirely. We aren't looking for a smoking gun. We're looking for a missing variable. And missing variables don't leave fossils. They leave uncertainty. This is why scientists involved in the Silurian hypothesis are so careful. The idea isn't that Earth definitely hosted a prior civilization. It's that our methods may be incapable of ruling it out. And that limitation should terrify us, because it applies forward as well as backward. If we disappeared tomorrow, how would future scientists interpret our impact? They would see a rapid temperature rise, a mass extinction, plastic residues, chemical anomalies. They would likely attribute it to natural causes amplified by chance. We would vanish into the noise. That realization forces a brutal thought. Our greatest achievement, global influence, is also what makes us indistinguishable from geology. Once intelligence reaches planetary scale, it stops looking like agency and starts looking like physics. And physics does not remember intentions. Now take this one step further. What if Earth doesn't just erase civilizations? What if it selects against them? Not consciously, not deliberately, but statistically. Planets that host intelligent life long enough to destabilize themselves may reset more frequently. Over billions of years, that would bias the record toward silence, which might explain something far bigger than Earth. It might explain the quiet universe. The Fermi paradox asks why we don't see evidence of advanced civilizations. The usual answers involve rarity, self-destruction, or cosmic distance. The Silurian hypothesis adds another layer. Maybe planets are efficient at cleaning up after intelligence. If that's true, then intelligence may be common, but persistence is rare. Civilizations flare up, reshape their worlds, and then fade into equilibrium again. Over cosmic time, that pattern would leave very little to observe. And suddenly, Earth stops looking special. It starts looking typical. Brian Cox often emphasizes that the universe is not built for permanence. Stars burn out, galaxies collide, even protons may eventually decay. Expecting civilizations to endure forever inside such a universe may be the wrong instinct entirely. Which leads to a deeply unsettling possibility. The goal of intelligence may not be expansion, but awareness. A brief moment where the universe becomes conscious of itself in a localized way. Then the moment passes. From that angle, the tragedy isn't that civilizations end. It's that they expect not to. An expectation shapes behavior. If you believe you are destined to spread forever, you may take risks that guarantee you won't. If you believe your planet is disposable, you may treat it accordingly. An earlier civilization might have reached that same crossroads and chosen wrong. Or chosen right but too late. Or chosen nothing at all, trapped between knowledge and action. We don't know. And that ignorance is the most important data point of all. Because it tells us something about ourselves. We are flying blind through deep time, assuming uniqueness without evidence. The Silurian hypothesis doesn't accuse us of arrogance, it exposes it. It reminds us that intelligence doesn't come with a survival guarantee. That understanding a system doesn't mean controlling it. That Earth has outlasted everything we call permanent. And if Earth has reset before, not violently, not maliciously, but inevitably, then the question shifts again. Not did it happen, but what would it take for it not to happen again? That question is far more dangerous than the hypothesis itself. Because unlike the past, the future is still mutable. And if intelligence is just another geological force, then for the first time in Earth's history, that force can recognize itself. Whether recognition is enough is something the planet has never tested. And that uncertainty is where the story moves next, because once you stop looking backward for lost civilizations, you are forced to look inward, at the one that exists now. Because intelligence doesn't just change environments, it changes incentives. Every technological civilization, no matter how it begins, eventually faces the same pressure: efficiency, more energy, more extraction, more control. The moment a species learns to manipulate its surroundings instead of adapting to them, it enters a phase where success is measured by speed and scale. That phase is incredibly powerful and incredibly short. Brian Cox often points out that evolution is conservative. It favors solutions that work well enough, not perfectly. But technology isn't conservative. It rewards optimization. And optimization, when applied to a finite system, always pushes toward limits. That's where things start to break. An early civilization doesn't need to be reckless to destabilize its planet. It only needs to be successful. Every improvement compounds. Every breakthrough accelerates the next. Energy use grows exponentially. Waste accumulates faster than biological cycles can absorb it. From inside the civilization, this feels like progress. From the planet's perspective, it looks like a spike. And spikes don't last. This is where the Silurian hypothesis quietly shifts from a geological curiosity into something closer to a warning label. Because if intelligence naturally pushes systems toward instability, then civilizations don't fail because of unique mistakes. They fail because they converge. Different cultures, different technologies, different values. Same trajectory. Energy use rises, environmental buffers erode, feedback loops accelerate, decision-making lags behind consequences. Then comes the point of no return, not because anyone crosses a line intentionally, but because the system has already crossed it. Earth's history is full of irreversible transitions. Once oxygen flooded the atmosphere, it never went back. Once complex multicellular life emerged, the planet's chemistry changed permanently. A technological civilization may trigger a similar transition, but one that ends with its own erasure. That doesn't require self-destruction in the dramatic sense. It can happen quietly, gradually, through systems becoming unlivable rather than explosive. And if that has happened before, it reframes how we should interpret Earth's apparent stability. Stability doesn't mean safety. It may just mean reset complete. Think about how little time intelligence occupies in Earth's history. Human civilization is a few thousand years old. Industrial civilization barely 2 centuries. That's less than a blink in geological time. Even if a prior civilization lasted longer than ours, say, tens of thousands of years, it would still vanish into statistical noise over hundreds of millions of years. Which means Earth could have hosted multiple technological rises and falls without leaving obvious traces. Not because those civilizations were primitive, but because time is ruthless. Erosion erases structures, plate tectonics recycles crust, oceans dissolve metals, microbes break down polymers, radiation scrambles isotopes. What survives are only the most persistent signatures, and even those blur. So if Earth resets civilizations, it doesn't do so violently or suddenly. It does so thoroughly. Now comes the hardest question. If prior civilizations converged toward collapse, why would ours be different? The common answer is awareness. We know more. We can model climate. We understand feedback loops. We can see the danger coming. But Brian Cox is careful here. Knowledge does not equal control. Understanding physics doesn't grant immunity from it. In fact, knowing the danger can sometimes make it worse, because it creates the illusion that solutions are inevitable. The belief that technology will save us can delay action just long enough to ensure it doesn't. That's another convergence pattern. Every advanced civilization likely discovers the same truths: that its planet is finite, that its systems are fragile, that its future depends on restraint. and then it must choose whether to act collectively against short-term incentives across generations. That's not a physics problem. It's a coordination problem. And coordination problems don't scale well. This is where the idea of Earth as a filter becomes unavoidable, not a conscious one, not a designed one, a statistical one. Planets that produce intelligence don't automatically produce wisdom. And without wisdom, intelligence amplifies instability faster than adaptation can compensate. The Silurian hypothesis doesn't suggest that Earth is hostile to intelligence. It suggests that intelligence may be incompatible with long-term planetary equilibrium unless something fundamentally changes. And that brings us to an even more uncomfortable possibility. What if intelligence is not meant to persist biologically? Brian Cox has hinted at this in discussions about the future of civilization, that the long-term survival of intelligence may require abandoning the very traits that define us now. Biology is slow, emotional, tribal, short-sighted. Technology accelerates faster than biology can evolve. That mismatch creates a tension that no amount of clever engineering can fully resolve, which means that civilizations might face a choice: remain biological and fragile, or transition into something else entirely. If a prior civilization reached that crossroads and failed to cross it, it would disappear. If it crossed it successfully, it might no longer leave biological traces at all. Either way, Earth would appear silent. This is where the hypothesis becomes deeply unsettling, because it removes comfort from both outcomes. No traces could mean extinction or transcendence, and geology cannot tell the difference. From Earth's perspective, both look the same. This uncertainty infects everything. It means the absence of evidence is not evidence of absence. It means the planet's calm surface could be the aftermath of intelligence, not its prelude. It also means that we cannot assume we are early. We could be late. We could be repeating a pattern already played out. And repetition is the most dangerous thing of all, because it breeds complacency. Civilizations that believe they are unique tend to ignore warnings framed as theoretical. But if Earth has reset before, then history isn't theoretical. It's cyclical, and cycles don't care about intention. They only care about thresholds. Once crossed, outcomes follow, which leads to a chilling realization. The most important archaeological site on Earth may not be buried ruins or strange isotopes. It may be us. Our emissions, our extinctions, our materials, our decisions. We are actively writing a geological layer that future scientists, human or otherwise, will struggle to interpret. And they may ask the same question we are asking now. Was this inevitable? Or did intelligence fail to recognize itself in time? That question doesn't belong to the past. It belongs to the present. And whether it becomes part of the cycle or the first break in it depends on something far more fragile than technology. It depends on restraint. Because if Earth resets civilizations, it doesn't do it because they are weak. It does it because they are powerful enough to destabilize their own foundation and slow enough to stop themselves. What comes next is unavoidable. If intelligence keeps reappearing and collapsing, then Earth isn't the experiment. We are. And the next part of this story isn't buried in stone. It's unfolding right now. This is where the Silurian hypothesis stops being about hidden chapters in Earth's past and starts colliding directly with one of the biggest unanswered questions in science. Where is everybody? For decades, astronomers have been puzzled by the apparent silence of the universe. With hundreds of billions of stars in the Milky Way alone, many of them older than the Sun, many of them hosting planets intelligent life should be common, or at least detectable. Yet the sky is quiet. Brian Cox often frames this not as a mystery to be solved with optimism, but as a reality to be faced with humility. The universe is vast, but it is also old. If technological civilizations were long-lived and expansionist, evidence of them should be everywhere. It is. The Silurian hypothesis offers a subtle but powerful explanation. Maybe civilizations don't last long enough to leave lasting cosmic footprints. Not because intelligence is rare, but because persistence is rare. A civilization doesn't need to vanish dramatically to disappear from the universe's records. It only needs to fail to spread beyond its planet before destabilizing itself. And if planetary self-destruction or stagnation is common, then most intelligent life never becomes visible at interstellar scales. This reframes the Fermi paradox entirely. Instead of asking, "Why haven't aliens visited us?" the question becomes, "Why would they survive long enough to do so?" In this view, intelligence is not the end of evolution. It's a brief, volatile phase. A flare, bright, complex, transformative. And short. Now imagine this happening across the galaxy. Countless planets evolve life. A smaller fraction evolve intelligence. An even smaller fraction develop technology. And almost all of them destabilize themselves before achieving long-term equilibrium or interstellar expansion. From the outside, the universe would look empty. Not because it lacks life, but because life keeps tripping over the same invisible threshold. That threshold isn't technological. It's systemic. Energy use rises faster than control mechanisms. Complexity increases faster than coordination. Feedback loops outrun decision-making. And planets, unlike civilizations, do not negotiate. This makes Earth's geological silence deeply ambiguous. We often interpret the absence of prior civilizations as evidence that intelligence is rare. But what if intelligence is common and ephemeral? If that's true, then Earth's past may not be unique at all. It may be representative. A case study. And that has consequences for how we think about our future. Brian Cox has pointed out that one of humanity's greatest misconceptions is assuming that intelligence naturally leads to stability. On the contrary, intelligence enables instability by accelerating change faster than ecosystems can respond. Evolution took billions of years to produce stable biospheres. Technology can destabilize them in centuries. That asymmetry matters. It means civilizations must consciously slow themselves down, something evolution never trained them to do. And across cosmic history, most may fail. Now consider how this affects the idea of alien contact. If civilizations rarely survive long enough to overlap in time, then the universe isn't just spatially separated, it's temporally isolated. Two intelligent species could exist in the same galaxy and never know it, separated not by distance, but by millions of years. One rises, one falls. No overlap, no signal, no record. From that perspective, SETI's silence becomes less surprising. We may be listening to a universe where most voices speak briefly and vanish before anyone else is listening. The Silurian hypothesis quietly suggests that Earth may not be early in the story of intelligence. It may be late. We might be living after countless attempts elsewhere have already failed. And if Earth has hosted multiple cycles itself, then intelligence doesn't just appear and vanish across space. It repeats across time. That repetition creates a haunting possibility. What if the universe is full of planets that keep rediscovering intelligence, only to lose it again? A cosmic Groundhog Day. Each civilization thinking it is first. Each convinced its problems are unique. Each underestimating how unforgiving complex systems can be. This is where optimism becomes dangerous. Because if the pattern is real, then survival requires more than innovation. It requires something evolution never selects for easily: restraint at scale. The ability to limit growth. The willingness to abandon profitable paths. The discipline to think in centuries instead of election cycles or quarterly returns. That's not impossible, but it's rare, and rarity is the universe's default setting. Now let's bring this back to Earth, not as a warning but as a mirror. If prior civilizations existed here, they likely faced the same choices we do now. They may have noticed environmental shifts. They may have understood the consequences. They may even have tried to adapt. But understanding does not guarantee success. Systems fail not because no one saw the problem, but because solving it required cooperation beyond what the system could sustain. Brian Cox often emphasizes that physics does not care about intention. The climate system, the carbon cycle, the biosphere, these operate on feedbacks, not morality. Once destabilized, they don't pause to see if you meant well. This means Earth doesn't need to be cruel to erase civilizations. It only needs to remain indifferent, which it is. And that indifference may be universal. If this is true, then the silence of the cosmos is not eerie. It's expected. Civilizations flare briefly, then disappear into planetary processes, leaving behind only subtle scars, scars that may themselves be erased before the next cycle begins. From that perspective, humanity's greatest challenge is not discovering alien life. It's not becoming invisible. Not geologically, not historically, not cosmically. The Silurian hypothesis implies that intelligence is not a stable endpoint. It's a test, and most fail it quietly. What matters now is not whether Earth had a civilization before us. What matters is whether any civilization ever figured out how not to need a reset. Because if none have, then the universe's silence isn't a mystery. It's a memorial, and we are standing inside the next inscription. What comes next is the hardest question of all, harder than detecting ancient isotopes or modeling lost oceans. It's the question of agency. If Earth resets civilizations naturally, does that mean collapse is inevitable? Or does intelligence finally give the planet a chance to break the cycle? That question doesn't belong to geology or astronomy anymore. It belongs to us. And answering it may be the only thing that determines whether this chapter ends the same way as the ones we can no longer see or not. It's a very scary fact, right? However, that's just the tip of the iceberg compared to what we will be sharing next. There is a quiet assumption hiding beneath almost every discussion about intelligence, progress, and survival. It's the idea that knowledge accumulates, that once something is learned, it stays learned, that civilizations move forward by building on the past. The Silurian hypothesis challenges that assumption at its core, because it suggests something far more disturbing. That intelligence may be capable of remembering almost nothing beyond its own narrow window of existence. Not because information disappears instantly, but because time is extraordinarily good at severing continuity. Human history feels long to us, thousands of years, empires rising and falling, entire belief systems erased, but on geological timescales, all of that collapses into noise. Brian Cox often reminds audiences that even the most dramatic events in human history barely register as ripples in Earth's physical record. The planet doesn't record stories, it records forces. Pressure, heat, chemistry, motion. Everything else is optional, which raises a brutal question. If a prior civilization existed on Earth, even one as intelligent as us, what would it take for its knowledge to survive long enough to matter? Stone monuments fail first, weather erodes them, vegetation swallows them, plate tectonics grinds them down. Metal artifacts corrode, plastics break apart under UV radiation, concrete cracks and dissolves. Even nuclear waste, often cited as a long-term marker, becomes chemically unremarkable after sufficient time. The deeper you go into the future, the more selective survival becomes. Eventually, only things encoded into planetary-scale processes remain. And intelligence is not one of those processes. This means that civilizations do not pass wisdom forward by default. They must actively fight against forgetting. And forgetting is Earth's preferred state. This is where the Silurian hypothesis exposes a terrifying asymmetry. The conditions that allow intelligence to arise are fragile and rare, but the conditions that erase intelligence are common and automatic. There is no evolutionary pressure on a planet to preserve its past thinkers. No feedback mechanism that rewards memory. No geological incentive for continuity. The planet doesn't care whether intelligence existed before. It cares whether the atmosphere remains stable, whether heat escapes, whether chemical gradients persist. From Earth's perspective, intelligence is a transient surface phenomenon, like a bloom of algae, or a wildfire. Brief, intense, self-altering. Then gone. This reframes how we think about progress. Progress assumes accumulation, but accumulation assumes memory, and memory assumes durability, none of which are guaranteed. In fact, most of them are actively undermined by planetary dynamics. Brian Cox has spoken repeatedly about humanity's tendency to project human timescales onto systems that operate far outside them. We assume that because something feels permanent, cities, institutions, nations, it must be durable. But durability is not about intention. It's about physics. And physics is merciless. Now imagine a prior civilization reaching the same conclusions we are beginning to reach now. They realize their planet is finite. They recognize feedback loops. They understand the dangers of destabilization. They may even try to encode warnings for the future. But how do you warn a species that doesn't exist yet? How do you transmit knowledge across millions of years? Language evolves too fast. Symbols decay. Context disappears. Even if a message survives physically, its meaning may not. A carved warning might be misinterpreted as art. A buried structure might be mistaken for a natural anomaly. A chemical signature might be indistinguishable from volcanic activity. The deeper the time gap, the less likely interpretation becomes. This is not hypothetical. We struggle to interpret artifacts only tens of thousands of years old. Entire cultures vanish from history with little more than fragments left behind. Now stretch that gap to millions of years. The Silurian hypothesis suggests that prior civilizations may not have failed because they were ignorant, but because no civilization can reliably communicate across geological time, which means every civilization wakes up blind. Each one inherits a planet without context. Each one believes it is first. Each one must rediscover the same truth independently. And that repetition is not comforting. It means intelligence may be trapped in a loop. Not because learning is impossible, but because learning doesn't persist. This leads to an unsettling possibility. What if Earth has hosted multiple intelligent species, each of them reaching a similar level of understanding, each of them recognizing the risks, and each of them still failing, not due to stupidity, but due to structural limitations? That failure would leave no monument, no ruins, no record, only subtle chemical echoes, if even those. And even then, future civilizations might explain those echoes away as natural variation, because the simplest explanation usually wins. Which brings us to a deeply uncomfortable mirror. What if our confidence that we are different is not evidence of progress, but a symptom of the same blindness? We believe we understand our planet better than any civilization before us. That may be true, but understanding is not the same as control. And control is not the same as survival. Brian Cox often emphasizes that intelligence does not exempt us from physical limits. It merely allows us to perceive them. Perception alone doesn't stop collapse. It only makes it more tragic when it happens. Now consider this from the planet's perspective. Earth has experienced mass extinctions before, 5 major ones. Each one erased dominant life forms that had existed for tens or hundreds of millions of years. Those species were successful by every evolutionary metric. Until they were. Intelligence does not grant immunity from extinction. It merely changes the mechanism. Instead of asteroids or volcanic supereruptions, the destabilizing force becomes internal. Energy use, resource extraction, atmospheric alteration, feedback acceleration. The extinction comes from within. From the planet's point of view, that distinction is irrelevant. A reset is a reset. This is why the Silurian hypothesis is not about ancient aliens or secret histories. It's about humility. It asks whether intelligence is actually capable of long-term planetary stewardship, or whether it inevitably overshoots, destabilizes, and disappears. If the latter is true, then Earth's silence about prior civilizations is not reassuring. It's ominous. because it implies that the planet has seen intelligence before. And it didn't stop the cycle. Now here is the most unsettling implication yet. If civilizations cannot preserve memory across deep time, then each civilization must rediscover not just science, but wisdom. And wisdom is far harder to rediscover than physics. Physics operates the same way every time. Human behavior does not. Every civilization must relearn restraint, relearn cooperation, relearn long-term thinking. And they must do so faster than the systems they are destabilizing. That is an incredibly narrow window, one that may close more often than it remains open. Brian Cox has hinted at this idea in a subtle way, that intelligence may be a transitional phase in planetary evolution, not a destination. A brief moment when matter becomes aware of itself, then rearranges into something else. Perhaps post-biological intelligence, perhaps something quieter, perhaps nothing at all. From that perspective, the Silurian hypothesis stops being speculative and starts being existential. It suggests that Earth may not be hostile to intelligence. It may simply be indifferent to its persistence. And persistence, not brilliance, is the true challenge. The planet does not test how clever you are. It tests whether you can stop, whether you can stabilize, whether you can choose not to pull every lever just because you can. If prior civilizations existed, their absence tells us one thing with chilling clarity. Knowing the danger is not enough. Understanding the system is not enough. Even predicting collapse may not be enough. The real test is whether intelligence can override its own short-term incentives. And history, both human and geological, offers little reassurance, which leads us to the hardest realization of all. If Earth has reset civilizations before us, then the question is no longer, did it happen? The question becomes, what would success even look like? What would a civilization that doesn't disappear leave behind? Not monuments, not machines, but stability. A planet that remains habitable indefinitely. A biosphere that continues without collapse. A civilization that learns how to exist without forcing a reset. If such a civilization ever existed, Earth would look exactly like it does now. Quiet, stable, alive. And that possibility changes everything, because it suggests the absence of evidence could mean either failure or success so complete that it leaves nothing to erase. In the next part, we have to confront that idea directly. Because if the goal isn't expansion, domination, or technological immortality, then what is intelligence actually for? And how do you know when you've passed the test, instead of becoming another chapter that time quietly deletes? Well, you don't, because nothing in physics guarantees that. In fact, when you strip away optimism and look only at evidence, intelligence looks less like an endpoint and more like a phase, one that may or may not stabilize before it collapses. This is where Brian Cox quietly shifts the conversation in a direction most people don't expect. Not toward ancient ruins, not toward secret histories, but toward limits. Cox often emphasizes that the universe is not built to preserve complexity forever. Complexity requires energy gradients, order, and constant maintenance. The moment those inputs fail, systems unwind. Civilizations are among the most complex systems we know. They depend on stable climates, predictable ecosystems, functioning social contracts, energy flows that don't spiral out of control, and a future-oriented mindset that evolution never trained us to have. Evolution rewards survival now, not survival 100,000 years from now. This mismatch may be the core flaw shared by every intelligent civilization, which leads to an unsettling possibility. What if intelligence almost always overshoots? What if the very traits that allow a species to dominate its environment also make it incapable of coexisting with that environment indefinitely? The Silurian hypothesis doesn't require ancient skyscrapers or buried machines to be true. It only requires one thing, that intelligence tends to destabilize its planet faster than it learns how not to. From that perspective, extinction isn't a failure of knowledge. It's a failure of timing, a race between understanding and consequence. And the planet always has the longer clock. This reframes the absence of evidence in a way that's deeply uncomfortable. Maybe we don't find traces of past civilizations because collapse happens before deep time signatures can accumulate. Industrial phases are brief. Geologically speaking, they're blinks. Atmospheric changes might last thousands of years, maybe tens of thousands, but tectonics, erosion, and chemical equilibration don't care. They reset the board, again and again. And if that's true, then Earth may have hosted multiple intelligent experiments, not sequentially, but independently, each one convinced it was unique, each one rediscovering the same physics, each one hitting the same constraints. Which raises a more troubling thought. What if intelligence itself is not rare? What if it emerges whenever conditions allow, but persistence is rare? That would flip the Fermi paradox on its head. The silence of the universe wouldn't mean intelligence is uncommon. It would mean intelligence rarely survives long enough to leave a lasting footprint. Brian Cox has hinted at this idea when discussing why advanced civilizations might not spread aggressively across the galaxy, not because they're peaceful saints, but because expansion is fragile. The more complex a system becomes, the more ways it can fail. Interstellar civilization require extreme stability across enormous timescales. And stability is not something evolution specializes in. Which brings us back to Earth. Earth is 4.5 billion years old. Complex life has existed for about 600 million years. Human civilization has existed for maybe 10,000 years. Industrial civilization, about 200. That's not a trajectory toward permanence. That's a spike. A sharp, sudden rise in energy use, complexity, and planetary impact. From a geological standpoint, we are not settling into equilibrium. We are perturbing it. Now imagine a prior civilization reaching the same phase. They industrialize. They alter atmospheric chemistry. They change land use. They disrupt cycles that evolved over millions of years. They gain awareness of what they're doing, but only after the momentum is already built. At that point, stopping is harder than continuing. This isn't speculation, it's basic system dynamics. Feedback loops don't care about intent. Once thresholds are crossed, systems behave differently. Brian Cox often stresses that climate, for example, is not a dial you turn smoothly. It's a nonlinear system. Push it far enough and it reorganizes. The Silurian hypothesis suggests that previous civilizations may have discovered this too late. Not because they were stupid, but because intelligence evolves to exploit environments, not to preserve them. Which leads to a terrifying idea. What if every civilization believes it's the exception? What if each one thinks we're different, we understand this now, we'll manage it? And what if most of them are wrong? This is where the hypothesis stops being about the past and becomes a mirror. Because if Earth has reset before, then our current confidence becomes suspect. Not because we lack data, but because confidence itself may be the repeating pattern. Every civilization thinks it's smarter than the last hypothetical one. Every civilization believes it has better tools, better science, better models. And every civilization underestimates the inertia of the systems it has already set in motion. There's another layer to this that's even more disturbing. Suppose a prior civilization did recognize the danger early enough. Suppose they tried to stabilize. Suppose they limited growth, energy use, environmental impact. What would that look like in the geological record? Almost nothing. A civilization that succeeds at not destabilizing its planet leaves fewer traces than one that fails dramatically. No massive carbon spike. No widespread synthetic materials. No abrupt extinction pulse. Just continuity. In other words, success is invisible. Failure is what leaves scars, which means our search for evidence may be fundamentally biased. We look for catastrophe because catastrophe is loud, but stability whispers. This creates a paradox. If we find no evidence of past civilizations, it could mean no civilization ever existed before us. Civilizations existed, but collapsed too quickly to leave durable traces. Civilizations existed and succeeded so quietly that Earth absorbed them seamlessly. Only one of those is comforting, and we have no reliable way to distinguish between them. Brian Cox has pointed out that planets don't advertise their histories. They don't label transitions. They don't preserve intentions. They only preserve outcomes, which means Earth may be full of erased attempts or none at all. And either option is unsettling, because in both cases, the lesson is the same. Nothing guarantees we'll be remembered. Nothing guarantees our knowledge survives. Nothing guarantees intelligence accumulates. If the Silurian hypothesis is even partially correct, then intelligence doesn't march forward through time. It flickers, appears, changes the planet, then disappears, and the planet moves on. This forces a shift in perspective that's almost existentially uncomfortable. It suggests that the true challenge of intelligence is not discovery. It's restraint, not expansion, but stabilization, not domination, but persistence. And persistence is not something evolution optimizes for. It must be learned deliberately, which brings us to the most unsettling realization yet. If Earth has reset civilizations before us, then we are not living at the beginning of a story. We may be living at a test point, a moment where intelligence either learns to coexist with deep time or becomes another transient layer in the geological archive. In the next part, we have to confront the hardest question of all. If survival leaves no trace, and collapse leaves only ambiguity, how would we ever know which path we're on? It's a hard question to answer, since we might never know while it's happening. Because the difference between a civilization that stabilizes and one that collapses doesn't announce itself in real time. From the inside, both feel identical for a very long while. Progress continues, technology improves, knowledge expands, daily life still works. The warning signs only become obvious in hindsight, and hindsight is a luxury extinct civilizations never get. This is where the Silurian hypothesis becomes almost cruelly subtle. It doesn't predict dramatic endings, it predicts normalization. Civilizations don't usually end with fireballs. They end with systems quietly losing resilience. Brian Cox often emphasizes that physics doesn't deal in morality or intention. It deals in thresholds. Push a system close to a limit, and everything looks stable right up until it is. And the closer you get to that limit, the harder it becomes to reverse course, because the system's own momentum resists change. This is not speculation. This is how stars behave, how climates behave, how ecosystems behave, and how civilizations behave. From inside a civilization, collapse never feels like collapse. It feels like stress, like transition, like uncertainty, like we just need to solve a few more problems. Every civilization believes it has time. That belief may be the most dangerous common trait of all. If a prior civilization existed on Earth, it likely didn't vanish overnight. It would have experienced centuries, maybe millennia, of gradual strain, environmental feedbacks growing stronger, social systems becoming more brittle, complexity increasing faster than understanding. None of those feel like an ending. They feel like growth pains. And that's the trap. The Silurian hypothesis doesn't require ancient beings to be foolish or reckless. It only requires them to be biological, constrained by brains evolved for short-term survival, not planetary-scale foresight. Which leads to a deeply uncomfortable possibility. What if intelligence is very good at discovering problems, but very bad at coordinating solutions at scale? That would explain why technological progress often outpaces governance, why solutions arrive late, why warnings are debated instead of acted upon. Brian Cox has pointed out that our understanding of Earth systems is extraordinarily recent. We've only had global climate models for decades, only had satellite observations for a few generations, only recently grasped how tightly coupled atmosphere, oceans, ice, and life truly are. Yet our impact began long before that understanding, which means knowledge tends to lag consequence. Now imagine a civilization 10 million years ago. They wouldn't have satellites. They wouldn't have global sensors. They wouldn't even know what planetary system meant in the modern sense. They would experience environmental change locally, drought here, flooding there, ecosystem collapse in pockets, without seeing the global pattern until it was too late. From their perspective, nothing would feel unprecedented. History would appear cyclical. And that's another danger. Humans are pattern-seeking creatures. We rely on past experience to predict the future. But planetary scale changes break that strategy because the past doesn't contain anything comparable. Brian Cox often stresses that one of the most misleading instincts we have is extrapolating linearly in a nonlinear universe. We expect tomorrow to resemble yesterday, but complex systems don't scale gently. They reorganize. That's why tipping points exist. That's why small changes accumulate invisibly until they don't. A prior civilization might have believed it was managing its world just fine, right up until the rules changed. And when the rules change, intelligence doesn't help much. Physics doesn't negotiate. This leads to a terrifying realization. If Earth has reset before, then collapse may not require external catastrophe at all. No asteroid, no supervolcano, no gamma-ray burst. Just internal imbalance. Just too much complexity too fast. Just systems outrunning their own stability. Which raises a question that cuts straight to the present. How would we recognize the difference between normal stress and terminal instability? We tend to look for singular threats, one disaster, one event, one villain. But collapse rarely comes that way. It comes as overlapping pressures. Climate stress interacting with biodiversity loss. Resource extraction interacting with social inequality. Technological acceleration interacting with psychological limits. Each manageable alone. Together destabilizing. And because no single factor is decisive, nothing triggers emergency brakes. Brian Cox has warned that the universe doesn't care how advanced your science is if your systems can't coordinate action at scale. Intelligence without coherence is fragile. Which brings us back to geology. Earth doesn't remember debates. It doesn't remember intentions. It remembers outcomes. If a civilization fails to stabilize, its signature fades. The atmosphere re-equilibrates. Ecosystems reorganize. Sediments bury disturbances. Time does the rest. Within a few million years, the difference between no civilization and brief civilization becomes nearly indistinguishable. And that's the cruel irony. Civilizations may be common, but only as brief experiments. This reframes the silence of Earth's past. It's not evidence of absence. It's evidence of efficiency. The planet is very good at cleaning up, which forces a final, unsettling shift in perspective. If Earth has reset civilizations before us, then survival is not guaranteed by intelligence alone. It's not guaranteed by technology. It's not guaranteed by awareness. Survival requires something evolution rarely selects for. Long-term restraint, the ability to act against immediate incentives, the capacity to prioritize stability over expansion. And perhaps most difficult of all, the willingness to stop doing things that work in the short term but fail in the long term. This may be the true filter. Not the emergence of intelligence, but the transition from exploitation to stewardship. Brian Cox has often said that the universe doesn't promise progress. It only allows possibility. Whether that possibility turns into endurance is entirely up to the system. If the Silurian hypothesis holds even partially true, then Earth is not hostile to intelligence. It's indifferent. It offers opportunity and then waits. What happens next determines what remains. And in the final part, we have to confront the question that sits beneath all of this. If we are part of a repeating pattern, is there any way to break it? If Earth has reset civilizations before us, then the most dangerous mistake we could make is assuming awareness alone is enough to save us. Because awareness does not equal control. Understanding a system does not grant immunity from it. And knowing a pattern exists does not mean you automatically escape it. This is where the Silurian hypothesis stops being a thought experiment and becomes something closer to a challenge. Not a warning from the past, but a question aimed directly at the present. Are we actually capable of breaking a cycle? Or are we just the latest version of it? Brian Cox often returns to a humbling idea when he talks about humanity's place in the universe. Intelligence is not special because it's powerful, but because it's fragile. Consciousness, technology, culture, these are emergent phenomena balanced on narrow physical margins. They only exist because conditions remain within tolerances. Push outside those tolerances, and complexity collapses. No malice required. No villain needed. Just physics. If earlier civilizations existed, then they likely believed, as we do, that progress would eventually solve the problems progress created, that more knowledge would naturally lead to better outcomes, that technology would outpace consequence. And to be fair, that belief isn't irrational. It's worked so far, but so far is doing an enormous amount of work in that sentence. Because geological time does not care about partial success. It only cares about persistence. This is where the conversation shifts from science to something more uncomfortable: responsibility across time. Humans are exceptionally good at optimizing short horizons. We plan in years, sometimes decades, rarely centuries, almost never millennia. Our institutions reflect that. Our economies reflect that. Our psychology reflects that. But planets operate on scales that make those horizons meaningless. Earth does not adapt to us. We adapt to Earth until we don't. If the Silurian hypothesis is even remotely plausible, then the true failure mode of intelligence isn't ignorance. It's impatience, the inability to slow down before destabilizing the very systems intelligence depends on. Which raises a brutal question. What would breaking the cycle even look like? It wouldn't look like colonizing other planets. It wouldn't look like exponential growth. It wouldn't look like technological acceleration without limits. Those are expansion strategies, and expansion is precisely what destabilizes closed systems. Breaking the cycle would look boring. Stability, maintenance, limits, a civilization that values equilibrium over dominance. A civilization that measures success not by how much it extracts, but by how long it lasts. And that may be the hardest idea of all, because nothing in our evolutionary history rewards that behavior. Brian Cox has pointed out that physics sets the rules, but biology plays the game. And biology is wired for competition, not permanence. It evolved in environments where growth was rewarded and restraint was punished. Planetary civilization flips that logic. Suddenly, restraint becomes survival. Suddenly, the traits that once ensured success become liabilities. Which means breaking the cycle may require something unprecedented. Not smarter technology, but different values. Not more energy, but less destabilization. Not conquering nature, but integrating with it. And this is where the hypothesis becomes deeply uncomfortable, because it suggests that the real test of intelligence is not invention. It's maturity. If previous civilizations failed, they may not have failed because they were incapable. They may have failed because they were unwilling. Unwilling to slow growth. Unwilling to accept limits. Unwilling to sacrifice short-term advantage for long-term stability. From that perspective, extinction isn't a punishment. It's an outcome, the natural result of unchecked feedback loops. Earth doesn't judge. It just rebalances, which means the silence of the past isn't ominous because it hides ancient ruins. It's ominous because it suggests that survival is harder than intelligence. Now here's the most unsettling implication of all. If Earth hasn't hosted a prior technological civilization, then we may be the first. And that doesn't make things better. It makes them worse. Because then we're not repeating a pattern. We're creating one. And the universe will remember only the outcome. The Silurian hypothesis leaves us with two possibilities, and neither is comfortable. Either civilizations arise often and disappear quietly, or civilizations arise rarely, and failure ends the experiment entirely. In both cases, the margin for error is thin. Brian Cox has said that the most precious thing in the universe may not be life itself, but conscious life, because it appears to be extraordinarily fragile against cosmic time. That fragility is not poetic. It's physical, and it places humanity in a strange position. We are powerful enough to alter a planet, but possibly not wise enough to preserve one. Yet, and that yet is everything. Because unlike hypothetical past civilizations, we have something they may not have had. Perspective. We know about deep time. We understand planetary systems. We can see our impact globally. We can model futures before they happen. Those tools don't guarantee success, but they make failure less excusable. If Earth resets civilizations, it doesn't do it maliciously. It does it passively, by letting systems run their course, which means the future isn't written, but it is constrained. The Silurian hypothesis doesn't ask us to believe in lost empires or buried machines. It asks something far more uncomfortable. It asks whether intelligence can learn to stop, whether a species can recognize that survival is not about reaching outward, but about holding steady. Whether we can become a civilization that doesn't need to be remembered in rock layers because it never destabilized its world enough to be erased. That may be the ultimate paradox. The most successful civilization would leave the least evidence. And if that's true, then the absence of proof in Earth's past isn't haunting because it suggests failure. It's haunting because it suggests how difficult success really is. The universe doesn't owe us continuity. Earth doesn't promise permanence, and intelligence left unchecked does not guarantee wisdom. If we are the first, then everything depends on what we choose next. If we are not the first, then everything depends on whether we learn faster than those before us. Either way, the planet is watching in the only way it ever does. Silently, patiently, waiting to see whether this experiment finally lasts.